If you're here to watch the world topper suffer, you're exactly in the right place. Hey guys, welcome back to my channel. I'm Anay Gupta and I'm so glad to have you here today. I'm the IGCSE Math World Topper, the AS Level Math World Topper, and my A Level results aren't out yet. Besides, I scored All India rank 3 at the IGCSEs, and then I did one better and scored All India rank 1 at my AS levels. For side quests, I was the IGCSE ICT World Topper, AS Level Physics, and AS Level Chemistry India Topper. So, I have a pretty fair understanding of how CAIE works. If this video has reached you, then Cambridge aka CAIE has hand delivered the solution to all your math problems. Well, math is either the subject you're most confident in or the subject you're least confident in. If it is your strength, then it is your best shot at gaining a world topper award. If it is not your strength, then it is the easiest subject you can clutch one day before the exam. Either ways, if you give me 1 hour for this video, I'm sure you'll enter the exam tomorrow more prepared, more confident, and ready to ace those marks. Alright, today we will be solving the May-June 2024 paper 12, which is exactly the pure mathematics paper I wrote en route to becoming the world topper in mathematics for the second consecutive time. I have exactly 1 hour to solve the entire paper alongside explaining my rationale, explaining the concepts, and also to pick out some key points and some mistakes to avoid in this text box above. For those of you who are silently praying for the world topper to not be able to manage his time or not maintain his 100% accuracy, I take this challenge. Let's see if you win or I win. I highly urge you to pick a pen and paper yourself and solve this paper with me and compare your solutions with mine. This was a paper I wrote 1 year ago. Let's see if I can maintain my 100% score a year later. Without further ado, let's begin and let's start the timer. Okay, the first question. The coefficient of x squared in the expansion of 1 minus 4x to the power 6 is 12 times the coefficient of x squared in the expansion of 2 plus ax to the power 4. Find the value of the positive constant a. Now, such questions can be tackled in 3 simple steps. Okay, the first thing that you want to do over here is always isolate the chapter. Okay, so if we take this question for example, we know that this chapter is of binomial expansions. Okay, the next thing that you want to do is try out the formulae. Okay, try out the formulae. So I am going to just try out the formulae for binomial expansion here. So the first expression, 1 minus 4x to the power 6, if I have to find the coefficient of x squared, that means that the power of 1 over here would be 4, right? Because 4 plus 2 makes 6. So coefficient of x squared in 1 minus 4x to the power 6 will be equal to 6c4, this is c, times 1 to the power 4 times minus 4 squared. Okay, so 6c4 is 15, minus 4 squared is 16. This gives me 240. Okay, the coefficient of x squared in the second expression, that is 2 plus ax to the power 5, is 5c3 times 2 cube times a squared, right? So 3 plus 2 makes 5. You have to ensure that the powers add up to the power in the original expansion. Okay, so 5c3 is 10, 2 cube is 8, and times a squared. That gives me 80a squared. Okay, so now I have tried out my formulae and I have got 2 terms over here. Now if I read the question, I have been given a condition that the coefficient in the first expansion is 12 times the coefficient in the second expansion. So you will always be given a condition. So your third step in any approach, okay, any chapter, any question, is to use the conditions to form an algebraic expression or form an algebraic equation and solve it for the variable x or whatever, theta, whatever. Okay, and form an algebraic expression or equation. Okay, these are your 3 steps in tackling any question. Now I'm losing some time here, so I'll just speed up a little bit. So 240 is equal to 12 times 80 a squared. We have been given the condition in this question, if you notice, guys. So 240 is equal, so 12 times 80 is 960 a squared. Now if I just make a squared the subject of the formula, that gets me 240 divided by 960, which is equivalent to 1/4. So a is equal to the square root of 1/4. Now a can be either positive half or a can be negative half, which brings me to my next key point. Okay, first find out all solutions. Okay, find out all solutions. So whenever you're given, say, a trigonometric angle, say theta, so find out all the solutions possible. If you're given polynomial equation, find out all the solutions for the variable and then accept or reject the possible solutions. So we have been given a condition that a is a positive constant. If you look at this, a is a positive constant. So I will say that since a is positive, a cannot be negative half. I have first rejected the one I don't want, and then I will accept the one which is possible. So therefore a can only be positive half. I have solved my question here, bagged my 3 simple marks. Okay, now I'm losing time, let's speed up. The curve y equals x square is transformed to the curve y equals 4x minus 3 the whole square minus 8. Describe fully a sequence of transformations that have been combined, making clear the order in which these transformations have been applied. Now we know that for a transformation based question, we need to look at the constant or the numbers in these equations. So we have 3 numbers, 4, minus 3 and minus 8. So we know that there will be 3 specific transformations. Now if you notice, there are always 2 types of numbers in a transformational equation. One is a coefficient and one is a term. Now what do I mean by coefficient? The coefficient is something that multiplies to a variable. So 4 is multiplied to x minus 3. So 4 is a coefficient. So whenever we have a coefficient, we will have a stretch. Whenever we have a term is something that is preceded by a minus or a plus sign. Okay, so 3 and 8 are both terms. So this will give us a translation. This will give us a translation. Okay, now we also need to figure out the stretch factor and we need to figure out the direction of the stretch and the translation. So is it in the y direction or the x direction? Okay, now if the coefficient is to the bracket, to the entire bracket, then the coefficient is in the stretch is in the y direction. But if it is to only the variable, okay, if it is only to the variable, like for example it would have been 4x minus 3 the whole square, then it would have been in the x direction. Okay, it would have been in the x direction. So here, since the coefficient is to the entire bracket, then the transformation that has been applied is a stretch in the y direction. So our first transformation is a stretch by factor of 4 in the y direction. And then our second transformation that has been applied is a translation. Now, translation happens in x and y directions. I can club both of these directions into one single vector. Now, we always know for translations, okay, whatever is inside the bracket is equivalent to the negative of the x direction. Okay, negative of the x direction. And whatever is outside the bracket is equivalent to the positive of the y direction. Now what do I mean? Okay, so if we take this example over here, okay, so translation by a particular vector. Okay, so we know that in the vector form, whatever happens in the x direction goes on the top and whatever happens in the y direction goes on the bottom. So my translation, the x direction of the translation would be negative of the inside. So negative of negative 3, which makes it positive 3, right? And for y direction, it would be positive of the outside. So positive of negative 8. So that makes it translation by 3 comma minus 8. Okay, so translation by 3 comma minus 8. So this is your entire answer. This gives you your 5 marks. Okay, let's move on to the next question. Show that the equation 7 tan theta plus upon cos theta plus 12 equals to 0 can be expressed as 12 sin squared theta minus 7 sin theta minus 12 equal to 0. Okay, now whenever we have our trigonometric identities question, we need to take care of two identities. First, sin theta upon cos theta is equal to tan theta, and sin squared theta plus cos squared theta equal to 1. For the AS level pure math paper, you need to know both of these identities thoroughly. So if I just start by expanding tan theta, so I can say 7 sin theta upon cos theta into cos theta, because there is already another cos theta that is there in the equation, plus 12 equal to 0. So I get 7 sin theta plus cos squared theta upon cos squared theta plus 12 equals 0. Okay, now if you see, I need to solve this equation a little algebraically here now. So I can just multiply the entire equation by cos squared theta. So 7 sin theta, cos squared theta, the numerator and denominator gets cancelled, plus 12 cos squared theta equal to 0 cos squared theta. But 0 cos squared theta is 0, so that again remains 0. Now I will apply my second identity. So if I know that sin squared theta, I'll just write them as S and C. Sin squared theta plus cos squared theta equal to 1. I can make cos squared theta the subject of the formula and say that cos squared theta is equal to 1 minus sin squared theta, right? So that is exactly the substitution I'm going to use. So 7 sin theta plus 12, 1 minus sin squared theta. And if you have been practicing enough past papers, you will be thorough with this substitution, is equal to 0. Okay, sorry, this is 0. So 7 sin theta, I open up the bracket, plus 12 minus 12 sin squared theta is equal to 0. Now, if you're just wondering, okay, wait, the sin squared theta term had to be positive. How come it is negative? Don't worry. We will just multiply the entire equation by minus 1. Okay, so we are just going to change the signs of all the terms over here. So it becomes minus 7 sin theta minus 12 plus 12 sin squared theta equal to minus 0, which is again 0. So that remains 0. And now I just rearrange the terms here. So 12 sin squared theta minus 7 sin theta minus 12, which is going to be 0. Now, hence solve the equation 7 tan theta plus upon cos theta plus 12 equal to 0 for 0 degrees less than greater than theta less than greater than 360 degrees. Okay, now first we need to solve the quadratic equation in sin squared theta. So 12 sin squared theta minus 7 sin theta minus 12 equals 0. Okay, so I'll first just start by solving the quadratic equation here in sin theta. So let's say that I can use the quadratic formula over here. So sin theta is going to equal negative of negative 7 plus or minus under root of negative 7 squared minus 4 times 12 times minus 12. Sorry for my illegibility over here a little bit. Divided by 2 times 12. Okay, so I can use the quadratic formula, which is x is equal to minus b plus or minus under root of b squared minus 4ac upon 2a, which is our quadratic formula. Okay, you can solve it by factorizing or by completing the square. You will reach the same answer. Okay, so sin theta is equal to 7 plus or minus under root of 625 upon 24. Root of 625 is 25. So sin theta is equal to 32 upon 24, or sin theta is equal to 7 minus 25, which gives us negative 18 upon 24. Okay, now we know that 32 upon 24 is greater than 1, correct? But sin theta cannot be greater than 1. It has to be between minus 1 and 1. So now we have found out both the solutions for sin theta, as I told you. Then we will reject or accept our solutions based on the conditions. So I will say that minus 1 is less than equal to sin theta is less than equal to 1, right? That means sin theta is between minus 1 and 1. Therefore, Sine theta cannot be equal to 32 upon 24. Hence, sine theta is equal to minus 18 upon 24. Now, I will find out theta. Another key point that comes up here is whether your angle is in degrees or radians. A lot of students make mistakes. They don't check whether they have to write it in degrees and radians. And the seventh point over here is your range of angles. Please take care of the range of angles specified in this question. Here it is between 0 degrees and 360 degrees. So firstly, very important to set your calculator to the degree mode, and then we can just find sine inverse of negative 18 by 24. So theta will be sine inverse of negative 18 by 24, and if you just find out the solutions here, that will equal 228.6 degrees, and the next solution will be 301.4 degrees, right? So that is our solution to the B part. Next question. The function f is defined as follows. Find an expression for f inverse of x. Okay, we have 46 minutes. Come on, guys, let's go. Now, in these situations, what you have to do is just substitute or just switch x and f of x. So how do you switch that? You say that x is equal to the root of f inverse of x. So in place of x, you put f inverse x, and in place of f of x, you put x minus 1. And now you make f inverse of x the subject of your formula. So f inverse of x is the subject of the formula, which is what you have been doing in IGCSEs as well. So I can say that root of f inverse of x is equal to x plus 1. So f inverse of x, if I just squared both sides, f inverse of x will be equal to x plus 1 the whole square. And I can leave my answer over here, or I can expand the brackets here, but this is what my answer should be ideally. The diagram shows the graph of y equals g of x, where g of x is equal to 1 by x squared plus 2 for x belonging to real numbers. State the range of g and explain whether g inverse exists. Okay, now, firstly, we can just solve this question by looking at the graph. So when we look at the graph, we can see that there is a point, or like a maximum point, okay? Like a maximum point. We don't know if it's a turning point or an inflection point, but it is a maximum point over here when x equal to 0, okay? And then the graph decreases. So I will say that when x equals 0, g of x is equal to 1 upon 0 plus 2, right? Just substituting the value of x in this equation. So g of x equals to 1 by 2 or half, right? Now, I know that g cannot be greater than half. Just by looking at this equation, g is always either equal to or less than half. Okay, now I find another very important, thing over here. We need to always consider asymptotes. Okay, in ranges, always consider asymptotes or domains. Always consider asymptotes. Now, what does this mean? Asymptote is a line, a flat horizontal or vertical line where the graph tends to but does not meet. So if you look at this, the graph is slowly approaching this x-axis, approaching the line y equals 0, but it is never going to meet that line, right? It is never going to meet that line, because if you notice, however long x square gets, like however large x square gets, it is still going to be a very small fraction. It is never going to be equal to 0. So that means whenever we have an asymptote, okay, then we have a strict inequality, okay? So asymptotes or min-max points. So asymptotes is going to be a strict inequality, okay, which means greater than or less than. But when we have a min-max point, then it is not going to be not a strict inequality, which will have less than or greater than symbols. So we know that our lower floor is 0, higher floor is half. So our range of g, our range of G is going to be 0 less than strict inequality because we have an asymptote at y equal to 0. Okay, so 0 is less than G of X is less than equal to half. This will get you your 1 mark. And explain whether G inverse exists. Now, we know that there are two types of functions, okay? There is either a one-to-one function or there's a one-to-many or many-to-one function, okay? One-to-many or many-to-one. So one-to-one means for one value of X, there is one value of Y. And for one value of Y, there is one value of X. But one-to-many means it is for one value of X, there is one value of Y, and many-to-one means for one value of Y, there is multiple values of X. Now, if you notice, let's say that I have this point somewhere here, okay, which is say 1 by 4. So for 1 by 4, I have two different values of X, right? There are two different values of X. So when I say at Y equals 1 by 4, what does X equal to? There are two different values of X which X equals to. So I cannot have a G inverse when there are two different values of X for that particular Y value. Hence, I will say that since graph or since the function is not a one-to-one function, G inverse doesn't exist. Now, if they had, for example, told us that instead of X belonging to real numbers, X is say greater than or equal to 0, which means X is, either positive or 0. That means that then we would only have this part to consider. And then this would have become a one-to-one function. So then the G inverse would have existed. The function h is defined by h of x equals 1 by x squared plus 2 for x greater than or equal to 0. So yeah, this is exactly what I was talking about. So now only the shaded region is what h entails. We do not have any x in the negative side of the graph. Okay, solve the equation h of x is equal to f of 25 by 16. Give your answer in the form a plus b root c, where a, b and c are integers. Now, whenever you have a big functions question, don't get confused, okay? This concept is called composite functions, and all you have to do is just substitute functions in place of x. Now, I'll teach you how to do that, okay? So first, let's solve our left hand side, okay? So let's say that f of x, I'll just copy down the question once, 25 by 16. Now I'll just substitute f of x here. So what was f of x? Root x minus 1. So h of root x minus 1. Okay, so we have substituted our question over here in the equation is equal to f of 25 by 16. So instead of x, okay, it says f of 25 by 16. So instead of x, I will substitute 25 by 16 over here. So I will say is equal to root of 25 by 16. Okay, sorry. Root of 25 by 16 minus 1. Now similarly, it says h of root x minus 1. That means I will substitute root x minus 1 into the x over here. So I will say 1 upon root x minus 1 the whole square plus 2 is equal to root of 25 by 16 minus 1. Now guys, guess what? We have used the formula for composite functions and we have got an algebraic equation. So if you look at our third key point, we will now just have to solve this equation and get our value for x. Now, how do we start solving the equation? We make x the subject of the formula. So I will first just let this be as it is and I will solve the right hand side of the equation. Plus 2. Now root of 25 by 16 is 5 by 4 minus 1, which will give me 1 by 4. Which is going to be 1 by 4. Okay, now if I just sort of cross multiply, this gets me 4 is equal to root of x minus, root of x minus 1 the whole squared plus 2. I can subtract 2 both sides, so 2 is equal to root of x minus 1 the whole squared. Now I can just square root both sides, so that gives me root 2 is equal to root x minus 1. I add 1 both sides, so root 2 plus 1 is equal to root x. I square both sides because I want to remove the square root, so root 2 plus 1 the whole squared is going to equal x. Now I know a plus b the whole square equals a square plus b square plus 2ab. That is an identity we have been learning for a long time. So I can just simply say a is x is equal to root 2 squared. So root 2 square will be 2 plus 1 square, which is going to be 1, plus 2 into a, that is 2 root 2 into 1. So x is going to be equal 2 plus 1, which is 3, plus 2 root 2. And this is your equation that has been solved. Alright, let's get to our next question, folks. The first and second terms of an arithmetic progression are tan theta and sin theta respectively, where theta is between 0 and half pi. Given that theta is 1 by 4 pi, find the exact sum of the first 40 terms of the progression. Okay, now I will get to my next very important key point, which is defining variables. And many toppers lose marks over here, because what they will do generally is write something like d is equal, because it is an arithmetic progression, I need to find the common difference. Okay, so d is equal to sin theta minus tan theta, right? Second term minus first term. But the examiner doesn't know what d is. Why will they assume what d means? So you have to tell them that let d be the common difference of this series or of the progression. Now you are defined what d means, and they know, okay, this is what you're calculating. So d is sin theta minus tan theta. Okay, I can just sort of leave it at this for now. Next, let Sn. Now I need to find the exact sum. Okay, I need to know the formula for my sum of 40 terms. I think it is given in the MF19 as well, but obviously it just helps to memorize the formula. So let Sn be the sum of first n terms, right? So Sn, the formula is going to be n by 2 bracket twice the first term. So the first term is tan theta, right? The first term is tan theta plus n minus 1 times the common difference, right? This is the formula for the sum of the first 10 terms of the series. So S of 40 is going to be 40 by 2 times twice tan theta plus 39 times sin theta minus tan theta. Okay, I'm sorry if I'm going a little out of the page, but okay, I think you get the point. Okay, now I can substitute my values of theta here. So S of 40 is going to be 20 times 2 into tan of 1 by 4 pi. So tan of pi by 4, now again you have to switch back to radians. So tan of pi by 4 is 1 plus 39 sine of pi by 4 is root 2 by 2 minus 1. Okay, so if I just multiply this will be 20 times 2 plus 39 root 2 by 2 minus 39. So 40 will be 20 times 39 root 2 by 2 minus 37. So this will become, this is going to equal to 390 root 2 minus 740. Okay, this is your final answer. Now if you also notice, they have said find the exact sum. Okay, they have also said find the exact sum. So you also have to be careful whether it is exact, or if they want you to put that into the calculator and give the answer to 3SF or a full answer. So if they have specified exact sum, then you need to leave it in this surd form. Okay, I don't really know what happened with the PC there. It's behaving a little weirdly these days, but let's get back to work. So find the sum to infinity of the progression in terms of theta. So we had already established that let R be the common ratio of the series. So R was going to be sine theta upon tan theta, right? The common ratio, like the common division over here. So that gets us to sine theta upon sine theta. And if we know that if something is going here below, we can just multiply that here, so into cos theta. So sine thetas cancel out, and we get r as cos theta. So sum to infinity is equal to the first term, that is tan theta upon 1 minus cos theta, which is your answer. Okay, given that theta is 1 by 3 pi, find the sum of the first 10 terms of the progression. Give your answer correct to 3 significant figures. So sum of to 10 first 10 terms is equivalent to tan theta. We know the formula here, 1 minus cos theta, okay, raised to the power of 10 upon 1 minus cos theta. So S10, if we substitute theta equals 1 by 3 over here, okay, is equivalent to tan of 1 by 3 pi, which is going to be root 3 times 1 minus cos of 1 by 3 pi is half. So half raised to 10 upon 1 minus half. Okay, so if I just put this into my calculator, okay, so root 3, I think 1 second guys. So I get the value of S10 to be 3.46, correct to 3 significant figures. Okay, now what I suggest is always putting the entire equation into the calculator rather than, small bits and pieces, like, just solving for root 3 first and then 1 minus half to the power of 10, because that increases the risk of something called as premature rounding. So we don't want to do that. We don't want to truncate our answers, too short, and then find out that we're just 0.001, 0.002 within the difference of the actual answer. So let's just keep it in the exact form until our final answer. Okay, next, the curved equation y equal 2x minus 8x raised to the power half has a minimum point at A and intersects the positive x-axis at B. Find the coordinates of A and B. Now we're entering the arena of calculus with coordinate geometry and circular measures. Okay, so these are supposed to be lengthy questions, but then if you have your basics sorted, these could be the fastest questions to attempt. Okay, find the coordinates of A and B. So it is given that A is the minimum point, so minimum point has a derivative of 0. So that means that first I can find dy by dx. So dy by dx would be 2 minus 8 into half into x to the power of minus half, right? We know that the formula for a derivative, dy by dx, or d of dx of a x to the power n, was going to be n a x to the power n minus 1. Now if you just figure out the variables and substitute them, you will get the answer very clearly. When you practice a lot, it really becomes muscle memory from there on. So we get dy by dx as 2 minus 4x to the power of minus half. Now I can say that at A, dy by dx is going to be 0, right? It is a minimum point. So at this minimum point, the gradient is going to be 0. So that means that 2 minus 4x raised to the power of minus half is going to be 0. So if I just solve this algebra, so I have used my formulae, now I'm going to solve my algebra. Okay, so I can say 2 root x minus 4 is equal to 0. So 2 root x is going to equal 4. Root x is going to equal 4 by 2, which is going to be 2. So if I just square both sides, x is going to equal 2 squared, which is equal to 4. At x equal to 4, y, I can now just substitute x equals to 4 in my original equation over here on the top, which is going to be, is going to be 2 into 4 minus 8 root 4. So this comes as 8 minus 16. So that is going to be y equals minus 8. So I have my coordinate of A as 4 comma minus 8. Okay, I'll write the coordinates together later. Now, what happens to B? It intersects the positive x-axis at B. So let's say there's a curve like this, for example. It intersects the positive x-axis at B. That means that y equals to 0. At B, y equals 0 because it is intersecting the x-axis. Okay, so we know that 0 is equal to 2x minus 8 root x. We can just substitute the equation, of y equal to 2x minus 8x half into the original equation for b. So if I just sort of do my algebra over here, okay, I can say that x minus 4 root x, I'm dividing the entire equation by 2, is going to equal 0. Okay, now I can factorize this equation further. If you see, x is the square of root x, so I can say root x minus 4 is equal to 0. So either root x is equal to 0 or root x minus 4 is equal to 0. Okay, so if root x is 0, then x is equal to 0. Or if root x minus 4 is equal to 0, so root x is equivalent to 4. That means x is equal to 4 square, which is 16. Now it says that it crosses the positive x axis. So I'll say since x is positive, I will first reject x is equal to 0. So x cannot be 0. That is why x is equal to 16. Okay, now at x is equal to 16, we have already established y equals to 0. So we have both our coordinates. So I will say that a has the coordinates 4 comma minus 8 and b has our coordinates 16 comma 0. Okay, and now we have solved the entire question for 4 marks. Next, the diagram shows the curve with equation y equals 2x minus 8x to the power half in the line AB. It is given that the equation of AB is y equals 2x minus 32 by 3. Find the area of the shaded region between the line and the curve. Okay, so we know that this coordinate, the x coordinate over here, is going to be 4. This coordinate is 16. We have already established that in our previous question. Now, we always know that we first have to, find out the chapter. So because we have to find out the area of the shaded region, we know that we will be using definite integration. That is the concept that I am going to use over here. Okay, now my next key point to note is that whenever we have the area of a graph, okay, the area of a curve, we always have to integrate the top curve, the equation of the top curve minus the equation of the bottom curve. So what am I going to do? The top curve, okay, objectively, you just have to look from top to bottom. So the curve on the top is the straight line, the 2x minus 32 by 3. This is my top curve. And this, the curve, the actual curve over here, this is my bottom graph or the bottom curve. Okay, so the area is going to be the integral of 2x minus 32 by 3 minus 2x minus 8x raised to the power half dx, right? You don't forget your brackets, okay? You don't forget this round brackets here, otherwise your entire equation will go for a toss. And we have our limits here, so from 4 to 16. Okay, it's a little quite muddled up, but I hope you get the point. Now I can just sort of simplify this. So even though these have a common denominator, I can split them up. So area is going to be integral from 4 to 16 of 2x by 3 minus 32 by 3 minus 2x plus 8x to the power half, right, with the derivative dx. So area, now I have two like terms, both have the power of x as 1. So I can further simplify them as integral of 4 to 16 minus 4 by 3x minus 32 by 3 plus 8x to the power half. Okay, now I know that my formula for an integral, so integral axn is always going to be ax n plus 1 upon n plus 1. And this is my formula for any algebraic integral over here. I just have to use that formula, guys. Very simple. So integral of minus 4 by 3x would be minus 4 by 3 times x squared, and whatever goes up is divided, so divided by 3 minus 32 by 3 times x. X is the power of, has a power of 1, so I don't need to divide anything, plus 8x raised to 3 by 2 divided by 3 by 2. Okay, and then I have my limits of 4 to 16. So if I just simplify everything here, I get it as minus 2 by 3 x squared plus 16 by 3 x raised to 3 by 2 minus 32 by 3 x from 16 to 4. Okay, This is a little jumbled up, guys, but I hope you get the point, okay? Also, we are pretty lagging behind pretty much on time. We just have 20 minutes left, so let's speed up. Area is now equivalent to, let's substitute our limits here. So negative 2 by 3 into 256 plus 16 by 3 into 16 raised to 3 by 2, which is 64, minus 32 by 3 into 16, minus, when we substitute 4, so we get minus 2 by 3 into 16 plus 16 by 3 into 4 raised to 3 by 2 is 8, minus 32 by 3 into 4. Now, when I put everything on this calculator, let's see what value do we get. Okay, so the value for x, the area that I'm getting here is 32 by 3, which is going to be your answer. Okay, next question. The equation of a circle is x minus 6 the whole square plus y plus a the whole square equals to 18. The line with the equation y equal to 2a minus x is a tangent to the circle. Find the two possible values of the constant a. Okay, now whenever we have a coordinate geometry question, we just need to imagine the question or imagine the diagram here. So I have a circle. Okay, it has this center of 6 comma minus a, because we know the formula of the circle. Okay, and so let's say I have a circle like this, for example. Okay, and now there is a tangent over here to the circle. So I need to find the possible values of the constant a. That means that at one particular coordinate, I will have both of my circle and my line intersecting. So I can start by finding the value or the coordinates of that point. Okay, so I know that I have been given two equations over here. Let me see if I can substitute one equation into the other. Okay, so I say x minus 6 squared plus y plus a squared equals 18. X minus 6 squared plus 2a minus x plus a the whole square equals 18. So I'm just substituting 2a minus x in place of y. Now if I open the brackets over here, I get x squared minus 12x plus 36, right? A minus b the whole square plus 3a minus x the whole square equal to 18. Just take it slow and easy, one step at a time. X squared minus 12x plus 36 plus 9a squared plus x squared minus 6ax equals 18. Okay, we have our formulas pretty sorted until now. Okay, now if I just sort of add everything up, that gives me 2x squared minus 12x minus 6ax plus 36 plus 9a squared equal to 18. Okay, now I'll just change some colors so that it's a little less monotonous. Now if you see, I need to form this as a quadratic equation because I have the power of x as 2. So to solve a quadratic equation, I need this right hand side to be equivalent to 0. Okay, so what will I do? I will just subtract 18 from both sides. So I will subtract 18 from the 36 over here. That gets me 2x squared minus 12x minus 6ax plus 18 plus 9a squared equal to 0. Okay, now I can divide the entire equation by 2. So that gives me x squared minus 6x minus 3ax plus 9 plus 4.5 a squared equal to 0. Now we use our next concept, which is that the fact that the line is a tangent to the circle. So since line is a tangent to the circle, then we know that the discriminant of this quadratic equation is going to be equal to 0, because there are exactly one possible values of x for the coordinate of a line meeting the circle. Okay, so discriminant is going to equal to 0. Discriminant, the formula for the discriminant is equal to b squared minus 4ac. So if we calculate the b squared minus 4ac, so x squared, first I will just isolate the x terms here. So I get x, and in the bracket I can say x minus 3a, and then I can club 9 plus 4.5 a squared as well. Okay, so the discriminant here is minus 6 minus 3a the whole square minus 4 times 1 times 9 plus 4.5a squared. Okay, so if I just sort of open the brackets up here, I will get that as 36 plus 9a squared plus 36a minus 36 minus 18a square equals 0. Okay, now I know that there's a positive 36 and a negative 36. They both cancel out. That gets me 9a squared plus 36a minus 18a squared equals 0. There are two a squared terms. I can do a simple algebraic mathematical calculation here. That gets me minus 9a squared plus 36a is going to equal 0. Okay, very simple. Now we need to use our factorization formulae. So I can say that minus 9, okay, minus 9a minus 4 is equal to 0, right? Minus 9a into minus 4 will give me positive 36. So either minus 9a equal to 0 or a minus 4 equal to 0. So a is equal to 0 or a is equal to 4. We have solved our question, guys. We have found our two values of a. Let's move on. For the greater value of a, find the equation of the diameter which is perpendicular to the given tangent. Okay, so now we know that the concept of perpendicularity is when the gradients, okay, so I have this circle here, I have a tangent here, and they want me to find the equation of this diameter, So I know if I can find a point on the circle, that point is the center, and if I can find the equation of the gradient of the diameter, I will find the equation of the diameter as well. So I know that the equation of the tangent gives me the gradient for the tangent. Okay, so gradient of the tangent, if I just check out the equation, is minus 1. The coefficient of x is minus 1. So I will say that minus 1 times the gradient of the diameter is equal to minus 1. Now I obviously have to define, let d be the diameter, blah blah blah. Okay, now gradient of the diameter is going to be negative 1 divided by negative 1, which will be positive 1, right? So I know that my equation of the diameter is going to equal y equal to x plus c, right? I know the gradient of the equation is going to be 1. Okay, now I need to find out a point of x and y, a pair of coordinates for x and y to substitute in this equation over here. Okay, so I know that the diameter will pass through the center of the circle has coordinates of 6, minus a. We have already established the fact over here. Now they have said that we need to use the coordinates of the greater value of a. So the greater value of a is going to be 6, minus 4. Right, the center has these coordinates. So if I just substitute them in this equation, I will have minus 4 is equal to 6 plus c, which gives me c will be minus 10. Hence, the equation of the diameter here will be y equals x minus 10. Okay, next question. Circular measures, it is given that r is equal to 0.4 centimeters. Show that the length EF is 2.4 centimeters. Now, if you notice, this is a isosceles trapezium. So this length over here will be 2 centimeters. Okay, let's say that this point is G, this point is H. I have annotated these points on the diagram so that the examiner can, see them for reference, and I can also use them in my explanations. Okay, so I will now notice that these two triangles are actually right angle triangles and they are congruent triangles. Okay, so I will need to find the length of FG, which is going to be equal to the length of HE. Okay, so let's say FG. Also, okay, one more thing, guys, we can use trigonometry to find the length of FG. So if this is 1 by 3 pi radians, and I already know that this is a right angled triangle or a right angle by perpendicular that I have drawn over here, then that means that angle ABG is going to be pi by 2 radians, correct? So this small little angle over here, okay, this little angle over here, this one is going to be angle FBG, will be pi by 2 minus pi by 3, right? This 90 degrees minus these pi by 3 radians, which is going to be pi by 6 radians. Okay, so I have already found out my angle over here. So if I use my my Socrates theorem here, so I have my angle, I have the length of the hypotenuse, which is given as 0.4 centimeters, right? The radius of the sector is 0.4 centimeters. So I can find the opposite side using the sine formula. So sine of pi by 6, which is my angle, is equivalent to the opposite side, which is fg upon 0.4. Correct? We just use our simple 10th grade trigonometry formula. So sine of pi by 6 is half, if you can put that into your calculator. So fg is basically 0.5 into 0.4, which is 0.2. Now since fg equals to he, right, your ef will be equal to 0.2 plus 2 plus 0.2, right? This is 0.2, this is 2, and this is another 0.2. So that gets you 2.4 centimeters. Okay, find the area of the plate and give your answer correct to 3 significant figures. So we need to know that the area of the sector is half r squared theta. In these circular measure chapters, you need to know your two formulae, that the arc length is equal to r theta, while the area of the plate is equal to half area of a sector is equal to half r squared theta. So I can say that the area of ABF, right, which is this sector over here, is going to be equal to half times r square, which is 0.4 squared times pi by 3, right? If you use figures like theta, r, you need to be able to define them. R has been defined for us, but then theta, we need to say, let theta be the angle ABF or something like that. Okay, so if I can just leave this here like this for now. I don't need to really simplify that. Okay, next we will find the area of the angle of the triangle BFG. Okay, we need to find the angle of the area of the triangle BFG. So I know that this is 0.2, correct? But if I just find out this length BG, that will allow me to just use the simple formula, half into base into height, and calculate the area of the triangle. So first, I'll use the Pythagoras theorem for this right angle triangle and calculate BG. So BG is root of 0.4 squared minus 0.2 squared, right? Just using the Pythagoras theorem here, guys. That will give me root of 0.16 minus 0.04. That will be root of 0.12. I can leave it in the exact form because I don't want to risk premature rounding right now. Okay, so now I can say that the area of triangle BFG is going to equal half into base, which is 0.2, times the height, which is the root of 0.12. Okay, and finally I can find the area of this rectangle, which is length times breadth. The length is going to be 2 centimeters and the breadth is going to be our newly found BG, which is root of 0.12. So area of my rectangle, which is BCHG, area of my rectangle BCHG is going to be equal to times root of 0.12. Sorry. Okay, let's go further. So now if I just find out the collective area of the plate, it is going to equal to root 0.12 plus twice both of these areas, because if you see the diagram here, there are 2 of these sectors and 2 of these triangles. So I need to multiply this area twice, which is going to be 0.1 root 0.12, right? Because I can just calculate half of into 0.2 is 0.1 plus half 0.4 squared pi by 3, right? So if I just compute this into my calculator, I get it as 0.926. Moving further, which I can say is equal to 0.930. Sorry, 929 blah blah blah. So 0.930. Okay, next, it is given that the perimeter of the plate is 6 centimeters. Find the value of r. Okay, Now, at the risk of just removing everything here, yeah, okay, pretty fine. Now, if I just start from A, this is R, I just need to find everything in terms of R, and then I can just form an equation and make R the subject of the formula. So this is R, this is R. Now this arc length is going to be R theta. The theta is pi by 3. I can just write it R theta for now. Okay, I can again draw my perpendiculars. So this is going to be 2, and I will need to find FG and FH again, okay, in terms of R, and this is again going to be R theta. Now if I just replace 0.4 with R, if I just replace 0.4 with R, then I can simply find FG using my same, SOHCAHTOA formula here. So sine FG is equal to, if you notice, 0.5 into your R, right? Sine of pi by 6 is 0.5, and your 0.4 was your R. So FG was equal to 0.5 R, right? Which is also equal to HE, which is the other side of the plate. So we have found out the sides here. Now let's find out the arc length AF, right? So AF is going to be equal to R into pi by 3, which is equal to pi by 3 R. Now I can leave my answer at that because I don't want to do premature rounding. Now I will just start from any point and just go clockwise or anti-clockwise and try to add up all the lengths that I have in between. So I start from A, let's say, and then I say R plus 2 plus R, okay, R plus 2 plus R plus DE, which is pi by 3, that this is also DE, plus pi by 3 R plus half R plus 2 plus half R, okay, plus 0.5 R plus 2 plus 0.5 R, plus again the arc length pi by 3 R is equal to 6 centimeters. Okay, so here if I just sort of add everything up, I get that as 3R plus 4 plus 2 by 3 pi R equal to 6. So R 3 plus 2 by 3 pi, I can just factorize these terms, is equal to 6. I take 4 on this side, that gives me 2, right? So that leaves me with R is equal to 2 divided by 3 plus 2 by 3 pi. So if I put it on my calculator, 3 divided by 2 by 3 pi, I get that as 0.393 centimeters, right? This is my answer. Okay, also here I missed adding the units. The units was centimeter square. Okay, that's another very key point that we need to note. Units. Forget the units, forget the marks. That's something I always say. Okay, I'm sorry, my computer crashed midway through this question. So I restart the question here. Also, I was running really low on time. I think I had like 3 minutes when I began this question. So realistically, it wouldn't be possible for me to complete this entire paper with explanation. Like I could solve the paper without explanations, definitely in 3 minutes. But then with explaining you the concepts and talking about the key points as well, it would take a little longer. So I've just given myself a little more time. We have 15 minutes now. Let's see if that should be sufficient. But yes, for that challenge of 1 hour, perhaps I humbly lose the challenge. Yeah. All right. But let's see the solutions to these questions, and I hope that you still have found some important takeaways to this question or to this paper and through this walkthrough. Okay. Let's start the timer. So determine the set of values for which of x for which f of x is decreasing. Okay, so if f of x is decreasing, then the gradients or f dash x is always going to be negative. But if f of x is increasing, then these gradients are going to be positive, right? They're slanting upwards to the right. So I say if f of x is decreasing, then f dash x is going to be equal to 0. So that means that this entire equation is less than 0. So x, 2x minus 3, the whole square minus 6x is less than 0. Now I can divide the entire equation by 6. So that gets me 2x minus 3, the whole square minus x is less than 0. Less than 0. So that gets me, if I just expand the brackets here, that gets me 4x squared minus 2 into 3 is 6 into 2 is 12. So 12x plus 9 minus x is less than 0. So 4x squared minus 13x plus 9 is less than 0. Now I can just see 4 plus 9 equals to 13. So if I just, factorize this equation, I can say 4x squared minus 4x minus 9x plus 9 is less than 0. Now if you don't, want to rack your brains on factorizing this, just go for the quadratic formula, and I think you should be pretty sorted with that as well. But then just take care of the inequalities, okay, which is greater than and which is less than. I'll tell you how to approach the inequalities, but let's just solve this quadratic first. So 4x x minus 1 minus 9 x minus 1 is less than 0. So x minus 1, 4x minus 9 is less than 0. Now whenever we have an inequality of less than, okay, then it is always going to be x less than something, and it is going to be between two values. Whenever we have a value of greater than, okay, it is always going to be x is less than something and x is greater than something separately. Okay, so in this case, let's find out the values of x. So we have x as 1, the critical values of x. So x is equal to 1, right? That's a boundary because 1 minus 1 becomes 0. And for this one, it is going to be x is equal to 9 upon 4. Right? These are the two critical values. Now, we just have to place x between these two critical values. So 9 by 4 is the greater value. That means 1 is less than x is less than 9 by 4. And for these values of x, f of x is decreasing. Okay, that is how it is going to be. Okay, let's go further. Given that f of 1 is equal to minus 1, find f of x. Okay, so now we have been given f dash of x. Now we need to find f of x. So the reverse of differentiating, which is integrating. But since we do not have any limits, this is going to be indefinite integration. Okay, now f dash x, I'll just copy the derivative for you. F dash x is equal to 6 2x minus 3 the whole square minus 6x. Now one approach is to just expand the equation and you get like a very simple algebraic form that you can integrate. But a simpler approach is to use something called as the chain rule. So f of x is equal to the integral of 6 2x minus 3 the whole square minus 6x the whole dx. Okay, so f of x is going to be 6. Okay, 6 is going to be common. Now 2x minus 3, I will obviously raise the power by 1, so into the power of 3, and I will divide it by 3. But when I have a chain rule, right, when I have a linear expression inside the brackets, I also need to divide by the coefficient of x. So I will also divide by 2. So I will say 2 times 3, right, minus 6x squared divided by 2 plus c, right? Plus c is very important in your indefinite integration. So f of x now becomes 6 upon 2 into 3 is just 1, right? Because 2 into 3 is 6. So f of x is now equal to 2x minus 3 the whole cube minus 3x squared plus c. Okay, now we have been given a condition f of 1 is equal to minus 1. So f of 1 is equal to minus 1. So we need to substitute 1 as x. Okay, remember f of x. So 1 is x. So x is equal to 1. F of x is equal to minus 1. So minus 1 is equal to 2 into 1 minus 3. So 2 minus 3 the whole cube minus 3 of 1 square plus c. So minus 1, 2 minus 3 is minus 1, minus 1 cube is minus 1, minus 3 plus c. So your c is equal to 3. So your f of x here is going to be 2x minus 3 the whole cube minus 3x square plus 3, right? This is going to be your solution. Okay, the equation of a curve is y equals 5 minus 2x to the power 3 by 2 plus 5 for x less than 5 by 2. A point P is moving along the curve in such a way that the y coordinate of point P is decreasing at 5 units per second. Find the rate at which the x coordinate of point P is increasing when y equals to 32. Okay, now we need to understand that this form of equations are something called as parametric equations, because there is a third variable, right, per second. So let's say that we have a variable of t that signifies time. Okay, so P is moving along the curve in such a way that the y coordinate is decreasing at 5 units per second. So the rate of change, so dy by dt is minus 5 because it is decreasing. Okay, because it is decreasing. I could put this as another key point as increasing or decreasing, right, in your dy by dx or dy by dt or whatever. So you have to take care of that, the signs in your answer. So if it is increasing, it's positive. If it's decreasing, it's negative, obviously, right? So dy by dt is minus 5. Now we have been asked, find the rate at which the x coordinate is increasing when y equals 32. So they have asked us to find dx by dt is what we have to find. Now using this curve, we can first just write down dy by dx, right? Dy by dx. So we will use the chain rule here. We will use the chain rule. So 3 by 2 comes down, right? 5 minus 2x raised to half. Now in the chain rule, while we are differentiating, this coefficient is multiplied. Here it was divided. Here it is multiplied. So we multiply another minus 2 over here, right? And plus 5 is obviously ignored. So dy by dx is going to be minus 3, 5 minus 2x raised to the power of half. Okay, now we know that we have been given dy by dx, we have been given dy by dt. So dx, so I can write dy by dx as dy by dt into dt by dx, right? So these dt's will cancel out and I will just get dy by dx. Okay, so dy by dx is minus 3, 5 minus 2x raised to the power of half equals minus 5, okay, into dt by dx. Now we are given a condition that y equals 32. So when y equals 32, x, what does x equal to? So when y equals 32, 32 is equal to 5 minus 2x raised to 3 by 2 plus 5. So 27 is equal to 5 minus 2x raised to the power 3 by 2. We just make x a subject to the formula. So if I just, take 27 raised to 2 by 3, that gives me 9. Okay, so what do I do over here, guys? If we have 3 by 2 over here, we will just inverse the power here. So 27 raised to 2 by 3 is equal to 5 minus 2x raised to 3 by 2 into 2 by 3, which makes it into raised to the power of 1. So 27 raised to 2 by 3 is 9, which is equal to 5 minus 2x. So x or 2x is equal to 5 minus 9, which is minus 4. So x is minus 2. Okay, x is minus 2. Now I just need to substitute my equation here. So minus 3, 5 minus 2x is 9. So 9 raised to half is equal to minus 5 into dt by dx. So 9 raised to half is 3. So minus 9 equals minus 5 into dt by dx. So dt by dx. So dt by dx is equal to minus 9 upon minus 5, which is 9 by 5. So dx by dt is going to be the reciprocal of that, right? 9 by 5 is dt by dx. So dx by dt is uska ulta. That will become 5 by 9. Okay, so that is our answer. Last question, guys. We have 4 minutes. Let's see if we can crack this. Come on. Point A on the curve is y coordinate 32. Point B on the curve is such that the gradient of the curve at B is minus 3. Find the equation of the curve where of the perpendicular bisector of AB. Give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. Okay, so we have this curve. We have a curve like this. Okay, for example, so point A is when the y coordinate is 32. Point B is when the gradient of the curve is 3, right? The dy by dx is minus 3. So we need to find the perpendicular bisector of AB. How do we do that? First, we will find the coordinates of A and B. So at y equals 32, we already found that x equals to minus 2, right? So we already found that x will be minus 2. Now we need to say that dy by dx is equal to minus 3 at B, right? What was our dy by dx? Our dy by dx was this expression here, right? This is the entire dy by dx. So minus 3, 5 minus 2x raised to the power of half is equal to minus 3. The minus 3's cancel out. So 5 minus 2x to the power of half equals 1. So 5 minus 2x is equal to 1. I square both sides. 5 minus 1 equals 2x. So x is equal to 2. Right? This is my entire thing that I found. At x equals to 2, what will y equal? So y equals 5 minus 2x raised to the power 3 by 2 plus 5, right? So y equals 5 minus 2 into 2. 5 into 2 into 2 raised to the power of 3 by 2 plus 5. So y will be equal to 5 minus 4 raised to the power of 3 by 2 plus 5. I know it's getting a little long and complicated, guys, but that's what. You just don't have to get scared of that. So that becomes 1 plus 5, which is equal to 6, right? So at x equal to 2, y equals to 6. Perfect. We have got a very nice little, values over here. So we know that A is minus 2, 32. B is 2, 6. Now we just have 2 points. We need to find the perpendicular bisector. So what will we do? We will find the gradient of AB. Okay, we will find the gradient of AB as y2 minus y1 upon x2 minus x1. So we will say 32 minus 6 upon minus 2 minus 2. So that gets us 32 minus 6 is going to be 26 upon negative 4. Okay, so the gradient of perpendicular bisector, okay, the gradient of bisector is going to be minus 1 divided by 26 by minus 4, which is going to be equal to minus 1 times minus 4 upon 26. So that becomes 2 by 13. Okay, now these are all formulas, guys. Coordinate geometry, very simple. You don't need to panic at all. So now I know that my equation is going to have a gradient of 2 by 13. Now since it's a perpendicular bisector, it is going to pass through the midpoint of AB. Okay, it is going to pass through the midpoint of AB. So I will say midpoint of AB is going to be x1 plus x2 by 2, comma y1 plus y2 by 2. So that becomes negative 2 by plus 2 is going to give me 0. 32 plus 6 will give me 38. Divided by 2 will give me 19. Okay, midpoint is this. So if I just substitute the values into y equal mx plus c, I know that the y-intercept is now 19. So I have my formula y equals to 2 by 13x plus 19. So 13y minus 2x minus 19 times 13 equals 0. Oh, we ran out of time, but okay. We just finished this question quickly. So I just multiply 13 to all the terms here and get them to one side. So 13y minus 2x minus 19 times 13 would be 247 is equal to 0. And that is your equation to the question. We have completed the entire May June 2024 paper, guys. I hope you enjoyed. I hope you learned something out of it. Yes, this was long. This was lengthy. And yes, I did miss my challenge goal. But I hope that I have explained it in detail enough. And yeah, for those of you thinking that yes, I have lost some shape, don't worry guys. If you ask me to solve this paper, I can solve it in under 20 minutes, okay? So that is not the problem, but I hope I have gone as detailed as possible. I hope I have, given you key points and mistakes to remember, and I hope that I have given you the confidence that you need for tomorrow's exam. If it gets too long, if it gets, a little overwhelming, just, take a break, take a pause, and then approach it with our three main steps to conquer these questions, that are: first, inspect the chapter, isolate the chapter; the second step is to try out the chapter's formulae; and then the third step is to form equations and solve the equations algebraically. Okay, so that is it for this video. I hope you enjoyed. If you like the video, please make sure to subscribe to my channel. If you have any questions, comments, if you have anything to say, any new topics you want me to address, put them down in the comments, and I'll make sure to get back to you as soon as possible. Like the video, share it with as many people as possible, and I will see you guys in the next video. Thank you so much for watching. All the best for the exams, and bye bye.